All right, so let's, without wasting our time, let's just start. I hope you guys remember the rules that we talked about the significant figures. Okay, I'm gonna turn off my camera because I'm gonna write on the screen. Okay, so I'm gonna turning off my camera. All right. Okay, so I hope you guys remember the rules. If you don't, we're gonna kind of, refresh the memory that what are the significant figure rules. There are two rules that we have to kind of keep in mind, in which the zero will not be counted as a significant figure if the given number does not follow any of this rule. It means all the digits including the zero are going to be considered as significant figures. So there are only two scenarios where you are not going to consider zero as a significant figure. The first one is if the number is less than one, right? If you see a number like 0.0013, like let's say 4, right? If you have a number which is less than 1, then all the zeros before your first non-zero digit. So let's find out where is your first non-zero digit. This is your first non-zero digit. So rule says all the zeros before your first non-zero digit are not significant figure. It means you're just not going to count this one, three zeros as a significant figure. So we are remaining with this many digits. So let's count 1, 2, and 3. So there are a total of 3 digits. It means there are 3 significant figures, right? Everybody understand this?
Yes.
Yes,
Yes,
Professor.
Yeah,
yes,
awesome. We are also going to practice like enough problems on this. So, yeah, we will have enough time to kind of, go through the problems and try to figure out where we're going to apply the rule and where we are not. But I'm trying to just kind of simplify this to help you understand what this rule means. Okay. The second rule, it says if the number is greater than one, so number has to be greater than one, and it must not have a decimal place. So if you see a number which does not have a decimal place, then you should apply this rule. So let's say, for example, 138000. If I give you this number, it looks like it is 138K, right? It does not have a decimal place and it looks like it is a greater than one. Then what is the rule? All the trailing zero. What do you mean by trailing zero? The zero which are on the tail end or on the right end of the number. So in this case, this zero is on the tail, this one is on the tail, this one is on the tail, right? So these are not going to consider as significant figure. If this is not a significant figure, it means there are only 1, 2, and 3. There are 3 digit which we are going to consider as significant figure. Is this clear?
Yes.
Yeah,
Yes.
great.
Yes, Professor.
Excellent, right? Just keep in mind it must not have the decimal point. If it have a decimal point, then this rule does not apply, and in that case all of the digit you see in the number are significant figure. Just for the example, if I give you a number like this, right? If you have a decimal place, so it's what the rule says, number has to be greater than 1, so yes it is, and it must not have a decimal place. In this case, we have a decimal place. It means we can't apply this rule. If we can't apply this rule, it means everything, all the digit you see in this number are significant figure. It means the answer should be 6 significant figure. All right, so just keep that in mind. And the third is not actually rule, it's just something that you kind of should be aware of. How you gonna consider the significant figure if the number is given in a scientific notation? So let's say, for example, if I give you this number, then how many significant figure do you have? So what you have to do, just keep that in mind. In a scientific notation, this portion of the scientific notation, you are not going to even look at it. All right, so totally you are going to ignore this portion of the scientific notation. All you're going to do is you are going to apply the same rule that we talked about to this number only. All right, so you apply the rule to only this number. You are not going to consider this at all. So you just forget about this, right? And whatever rule that we talked about, rule number 1 and 2, you apply those to that portion of the scientific notation. And that's it. All right. Other than that, it's still simple. So in this case, there is no, this all the non-zero digit, right? If there are all non-zero digit, it means there are four significant figure, right? So there are only two cases in which you are not going to count zero as a significant figure, and those two cases are rule number 1 and rule number 2. Every other cases, you are going to count all the zero, including the all the non-zero digit, as a significant figure. Okay, everybody's good?
Yes. What if you have a complex number like 120.012?
Yes, so that's a really great question, and that is what something we are going to practice in the next screen. Yeah, so we're gonna practice on that. Just remember, the rule only applies to this condition. So if the number matches this condition, then yes, you apply the rule. If the number does not meet with this requirement, you do not apply this rule. In that case, all the zeros that you are talking about will also be considered as significant figure. Okay.
Okay.
Yeah. Let me just give you that example here. Okay, what we I'm not just going to share the answer, I'm just going to let you think about it. Okay, so uh let's try this one. This is interesting. All right, 0.0080.
That's two significant figures.
Okay, so let's, great, everybody please give it a try. I think you should have the rule in your handbook as handout as well, which I have sent out, right? So open the handout if you haven't taken the picture of the last screen, right? Open the handout, read the rule, try to understand that and apply it here. And let's see how many of you can get the correct answer. Even if you don't get it, it's fine, right? We are just trying to learn here, so it's fine. Give it a try. Okay, for this, I'm going to give you 1 minute. Again, just a reminder, guys, if you have any question during this presentation, please use your microphone and ask me question, because when I have a full screen on my computer, I cannot see the chat box. Okay, so if you ask me some question in a chat box, I may not be able to see it and I may not be able to reply you back. All right. Okay, so yes, how many significant figures are there? So let's look at the number. I'm going to just help you to understand this. If you get it, I see most of you guys did get it right. Just in case if somebody is still, struggling, let's look at the number and think about the two rules that we talked about. Can we apply rule number 2? No, we can't apply rule number 2. Why? Because rule number 2 says number has to be greater than 1. In this case, number is not greater than 1. So rule 2, we just kind of forget about it, right? We're not going to apply that. Rule number 1, can we apply rule number 1 to this? Yes, we can, because it says, great, right? Because it says number is less than 1. So yes, it says that, yes, this number is less than 1. Now we're gonna look at the second, like the next portion, next sentence of the rule number 1, right? Which says all the zeros before your first non-zero digit are not significant. Let's find out how many zeros you have before your first non-zero digit. One, two, three. Yeah.
Yep.
You have this 30. According to the rule, it says this 30 are not going to be considered as significant figure. The rule does not talk anything about this 0, right? If it doesn't say anything, it means you are going to count that 0 as a significant figure. So let's count how many digits we are left with, 1 and 2. So the answer is 2 significant figure.
82.
Yeah.
Yep.
Excellent, excellent. Everybody, do you guys follow this?
Yes,
Yes,
Professor.
sir.
Right, it is simple,
Yes.
right? That's why I said like yesterday, stick to the words, right? Try to understand what the rule says. If you stick to the word and apply that, you will get the right answer. Let's try the next one. This would be a great idea, right? And probably you should be able to answer this fairly quickly now. So 30 seconds for this. Yeah. All right, great, great. So I'm just gonna repeat myself one more time. The rule number 2, can we apply that? No. Rule number 1, can we apply that? Yes, because the number is less than 1. Rule number 1 says all the 0 before your first non-zero are not significant. It means this I is not going to be significant figure. This is not going to be significant figure. Now, rule number 1 does not say anything about other zeros. It means every other digit you see in this number are significant. There are a total of 6 digits. It means there is 6 significant figure. Simple and easy. Yeah.
Yes.
Yes.
Everyone?
Yes, sir.
Awesome. Awesome. Great. Great. All right. So what I'm going to do now, I'm just gonna give you okay, I'm gonna give you like let's say 3 minutes. I should give you more. Okay, I'll give you 4 minutes to solve the question which you have in the first column, right? So try to answer all of this. There are a total of 6 number, right? Try to find out the significant figure for this 6 given number. Okay, we're gonna discuss that first, and then we're gonna move on to the next side. I think I help you in all the way that you may need to know. So probably you should be able to answer all of them correctly. But take your time. You have 4 minutes. You're gonna work on it. It's 11:18. All right, guys. Was it a good enough time? You guys need more time?
No,
No, we're good.
It's good? Everybody good? Yeah?
Yes.
Awesome. Awesome.
Yes.
Awesome. Great. Thank you, guys. So let's talk about the first example. Sorry. Let's talk about the first example. What do you think? How many significant figures are there?
Four. Four.
Excellent. Excellent.
Four.
Good job. Good job. Right? It is very simple. When if we are not following any of the rule number 1 or number 2, then all the digits, including your zeros, will be considered as significant figure. In this case, we do not have any zeros, so all of them are significant. The next one, how many significant figure do we have in the second example?
4.
Four.
Great job, right? Why 4? Because if you look at the number, it is 2 point something. It means in case if you're going to apply the rule, it's going to be rule number 2 because the number is greater than 1. However, as the second requirement of the rule number 2, it says it must not have a decimal point. In this case, we do have a decimal point, right? So there is no, like, it doesn't make sense to move forward with that rule number 2. It means every digit in this number are significant. Is 4. Excellent. Answer question number 3.
7.
7.
Everyone
7.
agree?
7.
Great job, right? Yes, it is 7. All the digit in this number are significant figure. Why? Because again, rule number 2, we can't apply. It has a decimal place. That's it, right? Moving on to the next example. How many significant figures?
5.
5.
5. Everybody say 5.
Yes.
5.
Great,
5.
great. Thank you, guys. Yes, it is 5. Again, you can't apply rule number 2 because it has a decimal point. The next one,
4.
4.
right? Looks like very simple and looks like you guys understand this. Excellent job, guys. As long as you see a decimal point and the number is greater than 1, every digit in this number is going to be significant. So I'm not going to ask you this question. I think everybody knows this. It's 5.
No.
Oh, okay.
Two.
No, 5.
Two.
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 It is 5 because
Do you
of
see
the,
the decimal?
yes.
Yes.
Oh, yeah.
I thought you
Oh,
you
yes.
guys
That's
got
a
it.
blessing. Yeah.
It's okay. Yes. So because of the decimal point, it should be 5. Right? Rule number 2. Yes, it is a trailing 0, but I did put the decimal point there. If it's a decimal point, you can't apply rule number 2. It means all the digits are significant figure. Is 5. All right. Everybody's good? Any
Yes.
questions?
Yes.
Okay. So because I think you guys got this, I'm gonna give you 2 minutes, which is more than enough now, to answer these 4 questions. Okay. So you have 2 minutes to answer these questions. All right. Should we guys discuss this? Are you guys ready? Yeah.
Yes.
Yes, sir.
Yeah. Okay. So the first example on the right side. First example on the right side. Please pick your phone.
3,
3.
3. Yeah.
3.
Everybody. Great job, right? It's yes, it is 3 significant figure. Okay. The next one.
3.
3,
So in this case, great job, guys. In this case, we are applying the rule number 2 because it does not have a decimal point and the number is greater than 1. It means the trailing zeros, the 0 on the right end of the number are not going to be considered as significant figure. These 3 are significant figure. Okay, so 3. The next one,
2.
2,
2, right? Again, the same reason, right? Trailing 0 without decimal point are not going to be considered a significant figure. And this one would be interesting.
3.
3,
3.
Great job, right? I hope everybody understand that this is the scientific notation in which we are not going to look at this portion of the number. We are only going to focus on this portion of the number. And if you apply the same rule that we know that it's going to be all digit are significant figures. So answer is 3. Yeah, everybody got this?
yes, sir.
Yeah.
Yes.
Excellent. Excellent. So beside this, I'm gonna give you like maybe like 1 minute or so. If you like me to kind of address any questions you have, right? Do you want to give me, do you want to give me any number that we want to work on, something like that? Or I think I cover every possible, or every different type of possible numbers. However, if you want me to, go over any particular number, please let me know. Anybody has any request? Any number you're curious about? Nope. Yeah, I think I covered like all the different possible numbers, but in case if you have any particular question. No. Okay. All right, great. Okay, so what we're going to do, we are going to move on from the significant figure into the application of the significant figure, right? So we know how to count the significant figure, but as we discuss, why do we need a significant figure? Because when we do the math, like not just in chemistry, but in all the science courses or maybe in the math as well, when we use our calculator, sometimes we get so many digits after decimal point, right? Or sometimes we get a really huge number. And we have, like, if somebody is allowed to round up as as per their choice, everybody may get a different number and figure. So in this case, what we're going to do, we are going to learn about, we're going to apply the significant figure rules for different mathematical expression. What are the mathematical expression that we're going to talk about? The first one we're going to talk about is multiplication and division. So whether you are just multiplying a number or just dividing two numbers or combination of multiplication and division, how many significant figure you have, like how many digit that should be in your final answer. That's what we're going to learn about. The rule says the fewest significant figure of the given number. It means when you're doing the math in which it is multiplication and or division, what you have to do, you have to find out how many significant figures are there in the given number. Out of the given number, whichever has the least number of significant figure, that many significant figures should be there in the answer. For example, if we look at this number, can you guys tell me how many significant figure do you see?
3.
3,
Great job, 3, right? How many significant figure do you see here?
2.
2.
2,
So which one is the least?
2. The bottom.
The bottom. 2 is the least number of significant figure. So what you have to do when you multiply this two number, right? When you multiply this two number, you just have to, okay, let's do the math, right? Can you guys do the multiplication and let me know what is the number?
1.692.
1.692.
1.692.
2, right? This is the answer when you use your calculator. However, let's see if I ask you a question that do the math and write down your answer in correct number of significant figure, it means you have to look at this. What is the least number of significant figure? It is 2. It means you have to have only 2 digit or 2 significant figure in your final answer. What does it mean? It means you're gonna apply the rule of rounding off, right? Do you guys know how to round off the number?
The answer would be
1.7.
Yeah, that's answer is right, 1.7. However, I'm just gonna ask you one more time in case if somebody doesn't know how to round off. Do you guys know how to round off, everyone?
yes.
Yes.
Yeah, great, great, great. So what I did, I just round off this number to 2 significant figure, right? So this is 1.7 and that is the right answer. Okay, you got this, everybody?
Yes.
Yes.
Yeah.
Sir, I'm sorry, how do you get 1.7?
Yeah, what we did, we just round off this number, the number that we have, 1.692. If we round it off, we get 1.7. Do you know what is rounding off means? Do you know what is rounding off? I'll just request everybody, like if you're not using your microphone at the moment, please mute, or at least make sure that there is no, something going on your background. Okay, thank you. So rounding off means, like if you do not know how to round off, please see me after one. I'll be more than happy to help you out, because in this session it looks like most of these guys knows that, so I don't want to waste everyone's time. Okay, but I'm definitely happy to help you, and I'm happy to explain you this. Okay, so please wait for me after 1 p.m. and we can discuss that. Okay,
I got it, sir. Thank you.
yeah, okay, no problem. Okay, so let's try to do the math on the second question. Right, I'm going to ask you to do the math, find out whatever answer you get, and I'm asking you to write down your final answer in correct number of significant figure. So let's see if you can understand this.
You want us to answer now or wait?
You can just put in a chat.
Okay.
I think it could be too early for everybody to answer that. So I'm going to look at the chat.
Oh, shoot.
All right. So I see some of you guys already, share your answer in the chat box, and looks like there are different numbers, right? So this is a division. So you are dividing 1.8 by 4.10, right? In general. So if you get like 7.38, it's not the right answer anyway. Yeah. Just want to remind you, right? It's a division. So just keep that in mind. Other than that, yes, if you do the division, I think you guys get around, like, I don't know the exact answer, but 439 something, right? Let's say if you get something like this, what we have to do, this is multiplication and division. It means we have to look at the significant figure for each given number. Now I'm going to ask you, how many significant figure do you see in this number?
2.
5.
5. 5.
Yeah, it is 5. Yeah. Why? Because its number is greater than 1 and it has a decimal place. It means you are not going to apply rule number 2. So all the digits are significant figure. So it is 5. If you look at the second given number, how many significant figures do you see?
3.
Same, right? Same explanation. It is 3. What does it mean? Your answer must have the least number of significant figure from the given number. So it should be 3, which you already have right now. So if you say 0.44, I think that could be the reason that maybe you guys are thinking about this number as a 2 significant figure, right? So it is not 2, it is actually 5. And if you know it is 5, then your answer, you will write your answer as 0.439. Get it, everyone?
Yes.
Right?
Yes.
Yeah, great, great, great. So remember this, if it's a multiplication and division, what you do, you're gonna look at the significant figure, how many significant figure you have in the given number, and whichever is a list, that should be the significant figure you should have in your answer. However, when you do addition and or subtraction, right? Either you're just adding two or three or five numbers, or if you're just subtracting 5 or 10 or 15 different numbers, how you should write your answer. Now remember, this has nothing to do with the significant figure from the given number. It has to do with the decimal place, right? So remember this, fewest decimal point of the given numbers. It means when we're going to look at this number, we're going to look at this, how many digits are there after the decimal place. So in this first number, how many digits do we have after decimal place? Everybody?
3.
3.
Yeah, I think everybody agree, right? It's simple. How many digits do we have after decimal place in this number?
1.
1.
What does it mean? It means your answer must have only one digit after decimal point. Okay, so remember, when we talk about addition and subtraction, now it has nothing to do with the significant figure. All we're going to focus on is how many digit do we have after decimal point. If we have 3 digit, if you have 1 digit, which one is lowest? 1 is lowest. It means your final answer must have only 1 digit after the decimal point. So I'm going to let you do the math, find out the whole answer, and then I'm going to ask you to write down the answer in the correct number of significant figure. All right, so anybody like to share the answer?
7.4.
7.4.
7.4.
All right, so I agree with you, but however, I'm just going to explain this to everybody, right? So when you do the math, yours should be 5, 3, 4, 7. This is the answer when you actually use your calculator or do the math. However, when we apply the significant figure rule, we know that it must have only one digit after decimal point. If it's only one digit, it means it should be 7.4. Yeah.
Yep.
Great job, guys. So I believe that you guys understand this, right? So there is no point of doing one more exercise on this, right? As long as you understand the rule. If you want to practice on this, you can definitely take the picture of this question, do the math, and you can share your answer with me later on. Okay, but we're gonna skip this part at the moment, right? So remember, addition and subtraction has a different rule, multiplication and division has a different rule. Anybody has any question on this?
Yes, I do have one question.
Yes, go ahead.
The last one that you have here, I know that you said we don't do it,
Mhm.
but do we remove the excess and then we do the minus, or do we minus it first and then remove whatever it's extra?
Yeah, so first you do the math just the way the number is given, right? So what I'm gonna do, I'm just gonna do the math right now, right? So there is nothing here. So if you just use this number, the whole number in your calculator, it looks like you're gonna get 9, not 2, 4, so 2,
52.6029.
12, 6, right? 52, yeah.
Yes, sir.
Okay, so you get this when you simply just use the whole, all the numbers which are given to you. Now, what we're going to do, we are just going to look at this, how many decimal point, how many digit do we have after decimal point? For the first number, we have 3. So we have 3 digit after decimal point. In this number, we have 4 digit after decimal point. Which one is the lowest? It is 3. How many do we have when we use the calculator or do the math? We have 4. It means we're going to round it off. When we're going to round it off, it should be only this many. However, yeah, however, it's rounding off rule because the number is greater than 5. So your final answer should be 52.603. Yeah.
Okay.
Okay, thank you.
Okay, again, if somebody doesn't know how to round off, please see me after 1 p.m. and I'll be happy to help you. Yeah. Any other question from this?
No.
No.
Excellent. So we are moving on from that now. Okay. That is a formula which I have shared with you already. And remember, this is not just a formula from the first chapter or second chapter. I just use this formula to help you understand that how you can do the math using such kind of formulas. Okay, so this formula is not just from the chapter 1 or chapter 2. It is from the different chapters. However, the density formula that you see, that's going to be in your first chapter. The specific heat is depending on which course you are in. It's going to be probably in the first as a part of the first exam. The temperature formula is probably as a part of your first exam. All right. However, the molarity formula could be the part of the second or third exam depending on which course you register for. Okay, so the formula for the density, I'm not going to explain you what is density, what is molarity, what is specific heat. You're probably going to learn all the theoretical part in your lecture, right? I'm not going to talk about that. However, I'm going to explain you how to use this formula to solve the problem. All right, so let's talk about the formula for the density. The reason why I have used this 3 formula, because I want to explain you something. Whenever you have formula in this form, right, density, what is density means? It means mass over volume, right? So when you divide the number for the mass by the volume, you get the density, right? Now, the same formula is for the molarity, right? Of course, all of this represents a totally different concept. However, the way we do the math is still the same, right? What we have, let's say, if we just want to generalize this, what we have x is equal to y over z, right? We have one quantity on this side, there is another quantity in a numerator and another quantity in a denominator, right? So every time when we do the math, it's going to be similar. The specific heat formula is also similar. In this case, I'm just going to abbreviate this specific heat. The formula is heat divided by mass times change in a temperature, right? Again, the formula looks like the same. Instead of just one quantity, which is given in a denominator for both of this formula, now we have two quantity given in the denominator. So instead of we can say x, y, z, we can say x is equal to y over z times we can say u, for example, right? Every time when we do the math on this kind of formula, we can apply the same steps, same rules. So I'm going to talk about that. Okay. The unit I have given to you, right? Again, you need to understand what is density, what is molarity, what is specific heat in order to understand the unit. However, I'm just going to simplify this for you. If you know the formula for any for anything, right? When you know the formula for density, when you know the formula for molarity, all you have to do is simply write the unit for each of this value. Mass, what unit do we use for the mass? Generally we use gram. Volume, what unit do we use for the volume? Ml is unit we use for the volume. It means the unit for the density is grams per ml. We don't have to remember the unit if we remember the formula, right? So it is very simple. The same way, mole, we use the mole in as a mole. So mole, volume, most of the time in this case, we measure the volume as a liter. So the mole over liter is the unit for the molarity, and so on, right? So I'm just giving you like a general idea that if you want to, if you know the formula, all you have to do is write down the unit for each of that variable or the quantity, and that's how you can get the unit for that particular quantity. Okay, so just remember that. In terms of,
Professor,
yes, go ahead.
I'm so sorry to cut you off. So for specific heat, the unit that we're using is calories over, is that a G, is that G
Yeah.
times degrees Celsius?
Yes, that's right. So I'm going to write that down here. What we have, heat, right? What is the unit of heat, right? What is the unit of heat? Is generally measured in calorie, okay? Over mass. Mass is generally measured in gram. Change in the temperature. We generally measure the temperature in degree Celsius or degree Fahrenheit, right? So this is the unit for the specific heat. So all I did is, if I know the formula, I'm just gonna write down the unit for each of this portion or the quantity or in the within the formula in able to be able to find out the final unit for the specific heat. Did I answer your question? Yeah.
So from my understanding, yeah, that answers my question. And
Yeah.
I'm sorry, you said that it's grams times degrees Celsius?
Yes, so this asterisk represent the multiplication, right? So multiplication or asterisk is a so gram calorie over gram times degree Celsius. Okay, you can say multiplication like this, or you can just put the asterisk. Even if you don't put anything, it should be fine as well. Gram degree Celsius. Just keep some space in between them so we know. Okay.
Thank you.
Yeah, no problem. Any other question? All right. No? Okay, great. And there is a 3 formula which I like, I would say you should remember, or at least keep those formula handy. That is for the temperature, right? So I generally prefer to remember these 3 formula, right? However, there is, like, if you're using a different book, they may represent this formula in differently. Instead of giving you as 1.8, they may give you 9/5. However, this number is not going to change. Like when you do the math, your answer is still going to be same. So for me, this is the easier way for me to remember the formula. However, if you want to remember in this way, you can definitely do that. Okay, so it would be great if you can have this formula handy with you or remember the formula, right? Generally during the exam, professor do not give this formula. Either you should remember this or you should have it handy. Okay, so please, like I do prefer to remember this 3 formula. In case if you like to remember in this form, you can definitely do that. So please spend some time to kind of remember this formula. Okay. And at the moment, yeah, we can work on this problem too. All right. In the next slide, I'm going to show you how we can find out the values using this 3 formula: density, molarity, and specific heat. And we can also talk briefly about how we can do the temperature conversion. So what I'm going to do, I'm just going to ask you to take the picture of this. I know it looks messy at the moment, but please take the picture of this. We are going to use this formula, the temperature formula, yeah, to work on a couple of problems just for your practice before we talk about the periodic table. All right. I'm going to give you like 10 more seconds to take the picture. All right, moving on. Sorry. Yeah, so moving on. All right, so how are we going to use the formula that we talked about? So let's say the example is, the problem says, if a compound has a mass of 9.02 gram and the density of 1.45 grams per ml, find out the volume. Now, you already know the formula, right? The formula is this: density is equal to mass over volume. Let's look at the formula. What we know, right? As a part of the question, the mass has been given, so we know the mass has been given. Density has been given, so we know the density has been given. What do we have to find? We have to find out the volume. The reason why I choose this problem, because students struggle when we have to find out something which is in a denominator, right? So the formula looks like this. Density is equal to mass over volume, right? Now, if I'm just going to plug in the numbers, it looks like this: 1.45 grams over ml is equal to 9.02 grams over volume. We don't know the volume. We have to find out the volume. Yeah. So if you guys are good in math, probably you know how to solve this. If you don't have a strong math background, what I'm going to do, I'm just going to make it easier for you. Okay, so if you want to follow my method, you can. If you don't want to follow my method, it's completely fine. However, whenever you see the formula like this, right, the one that I explain you, x is equal to y over z, and if you have to find out the z, what you have to do, right? I am explaining you that if you have a formula like this, x is equal to y over z, and z is something you have to find out, all you're going to do is you're going to multiply by z on the both side. When you do that, by doing so, you should be able to cancel out the z from the denominator and the numerator, and final formula looks like x z equal to y. You always should do this to make this formula look simple. All I'm going to do, I'm going to apply the same concept in this density formula. All I'm going to do, because we have to find out v, and it is because it's in denominator, all I'm going to do is multiply both side of this equation by v. So I multiply left side as well as the right side with v. If I do that, I should be able to cancel out the v from the numerator and the denominator. So my final formula looks like Vd is equal to m, right? And in this way, I managed to bring volume in the numerator, right? Do you guys follow this, what I did?
Yes.
Yes, sir.
Yeah.
Yes, sir.
Again, it depends on your math skill. If you're more proficient, you can do the other way as well. However, I'm just trying to explain you that you will always get the right answer if you follow the method, right? Once you have this, what we know the mass has been given and the density has been given. So every time when something is given and something you need to find out, you want to isolate what you need to find out. In this case, we have to find out v. It means we want to have a v on one side of the equation and everything else must be on the other side, which we don't have it here. We have v and d together on this side of equation. What does it mean? It means we want to get rid of d. We don't want d on this side. So for that, we are going to divide by d on this both side of the equation. By doing that, we are able to cancel out d. Now the final formula look like this: v equal to m over d. What we did here, we actually isolate v. That was the purpose, because if you want to find out something, it has to be on the one side of the equation and it must not have any other quantity along with it, right? So what we have now, we have v on one side of equation and everything else for which we already know the numbers are on the other side. All I'm going to do is I'm going to plug in the numbers. For mass, what is the number I have? 9.02 gram. For density, what number do I have? 1.45 grams over ml. I'm going to ask you to do the math and please let me know the answer.
Are we supposed to express our answer in significant figures?
Yeah, let's try that. Yes.
6.22.
Yeah, 6.22.
ml.
ml. Yeah.
Yep.
So great job, right? Anyway, in this case, there is 3 significant figure on the top, 3 on the bottom. So it wasn't like a kind of, any challenging, right? It was simple that we cancel out this gram from the top and bottom. We have ml which is the 1 unit left. So we can say our final answer is 6.22. So the whole purpose of me explaining this concept is this, right? If you ever has to find out something which is in a denominator, I would definitely suggest you to follow this. So if you like this method, please do that. If you do not like this method, you can do the math the way you like. Okay, but I think this would be very helpful. Anybody has any question or confusion?
I'm lost, Professor.
Lost. It was lot of rearrangement of the equation. That is the reason, or in the math.
No, the rearrangement. I didn't see how you get the 6.22 ml.
The 6.22, like, okay. So let me go one more time. Let me see what I have in the next slide. Just give me 1 minute. Let me see what I have in the next slide. Move and the water. Okay, this one is simple. Okay. All right. So generally, right? Let's say you use this formula. Okay. Should I give you a number? Okay. So wherever you have to find out, I'm gonna repeat this one more time, right? If you need to find out a quantity which is in a denominator of the equation, what you're supposed to do? First of all, if it's in a denominator, it's not going to be easy for you to do the math. So why don't we bring it to the numerator? Yeah. To bring it to the numerator, what we have to do, we have to multiply by that quantity on the both side of the equation. Remember, if we are multiplying on any one side, it is not right. We have to multiply on the both side. Okay, so we are multiplying on the both side. When we do that, we should be able to cancel out the quantity which is present in a numerator and the denominator and either side. In this case, it's right side, right? So finally, what formula we get? We got V multiplied by D equal M. Okay. Now we have this formula in which all three quantity are on the numerator, right? There is nothing in a denominator. So that's good for us. However, by using this formula, can we answer this question? Probably not. Why? Because we need to find out the answer for V. If we need to find out answer for V, it means we have to have V on one side of the equation and everything else or all the other quantity must be on the other side. What other quantity do we have on the side of the V? We have D on this side, which we don't want. It means because the D is in a numerator, we are going to divide by D on left side and the right side of the equation. If we have D on the numerator and denominator, of course, we can cancel out. That's how we get our final formula, which is V equal to M over D. And now we have the value for M, which we plug in here. We have the value for D, which we plugged in here. Now you're simply doing the math, 9.02 divided by 1.45. And that's how you get 6.22. Does it make sense?
Yes, sir. Thank you so much. I got it.
Yeah, great, great. Anyone else has any question? Okay, so the purpose is to bring it on a numerator and then rearrange the formula depending on what you have to find. Okay, so that was the goal. And I hope it was helpful. This one is a really simple question, right? I'm gonna let you do this math because I think that this is really simple. I'm gonna give you like, let's say two minutes to solve this, right? I gave you the formula, right? You know the formula, you know the numbers which is given as a part of the question. All I'm going to do is plug in the numbers in the formula and do the math and let me know the answer. Okay, I'm going to give you 2 minutes for that. So 11:59. Okay, guys. Anybody has any answers?
Yes, 0.015.
Excellent. 15.3. Okay. So,
I have a question, right? The formula say the mole over the liters. That's mean we need to change the ml to liters, right? Millimeter to the liter first. Yeah, that's one.
yeah, that's right. However, I do need to explain you that. All I wanted to do is I want you to plug in this number and get the answer. I'm going to explain that to you that, okay, the formula says this. So this is something that you have to keep in mind, right? So let's just keep it simple for now. And let's just try to understand what it says, right? Molarity. Molarity means the formula says mole over volume. What is the number of mole do we have? So yes, we have the number of mole. What we have else? We have the volume. It means whatever we have as a part of the question is on the right side of this equation. It means we don't need to shuffle this equation, right? All we have to do is just plug in the number 6.9 mole over 450 ml. If we do the math, it looks like, yes, you guys got the right answer. 15 grams per ml, sorry, mole per ml. Yeah, everybody got this answer?
No.
No, isn't it? What was the math?
Because I convert milliliters into liters first.
Yeah, I'll do it too.
Okay, no, it's okay. Like we are going to do that. I'm just talking about in general. Yeah, of course we're gonna convert that into liter. All right. So for most of the students didn't kind of realize that at the moment, right? So, and my goal was just to explain you that, okay, all you have to do is plug in the numbers and that's how you get the answer. That's how you can use the formula. So yes, this part is right up to the sense what I ask you for. However, if you look at the formula for the molarity, the unit for the molarity was mole over liter. And that's what you're gonna learn in your lecture, that the unit for the volume is always liter wherever we talk about molarity. Molarity is all in the molarity, we always measure the volume in liter. What does it mean? It means we have to convert this into liter. Okay, so now what we have 0.015 mole over ml, right? What do we have to do? We have to convert into mole over liter. What it simply means, we need to convert ml into liter. Do you guys agree? The mole is still there. However, it is done. We already have this. What we need to do, we need to convert ml into liter. Now, do you guys remember what is the relationship between liter and ml? We talk about
10
yesterday.
to the -3.
Great job, right? 1 ml is equal to 10 to -3 liter. If you don't remember, it's fine. The table has already been given to you. Make sure you look at it, review it, try to remember this. Okay, so this is right up to this point. Now we're going to talk about the unit conversion that we learned yesterday, right? What do we have to do? In this case, we have to convert the unit from ml to liter. However, this is challenging too. So what I'm going to do for the unit conversion, as you guys remember my rules, right? Always write down what is given to you. In this case, this is what we have. This is what we found out, right? So I'm going to write down, this is what I have. Now you're going to multiply that with the proper version of the conversion factor in such a way that you can cancel out the given unit, or in this case, the unit we have, into the unit we want, right? Now, if I'm going to ask you which way we are going, which side of this equality factor goes in a numerator and which side goes in a denominator? Can anybody answer that?
Milliliter goes on top.
Milliliter goes on top. Anyone else?
Agreed, milliliter on top.
Yeah, and millimeter in the top.
Excellent, excellent. The reason is we are trying to convert ml into liter. If you want to convert the ml into liter, it means our goal is to cancel out the ml. If you want to cancel out the ml in the given number or the number that we have, ml is in a denominator. If ml is in a denominator, we're going to put ml in the numerator. To do that, it means this side goes in a numerator. So the 1 ml is going to go on the top, 10 power minus 3 liter goes in the denominator, ml from the top and the bottom cancels out. If you do the math, right, I'm going to let you do the math, let you use your calculator. You remember we talk about how to use your Google calculator or any other calculator to do this kind of conversion. I'm going to let you do the math and let me know what is your final answer. And let's try one more thing, right? I'm going to ask you to answer this in a scientific notation. So let's try that. Right? Please write down your answer in a scientific notation. So this will be a great practice problem. The answer is, okay, so I think everybody got the answer as 15, right? Did you guys get the answer 15?
Yes, sir.
Yes.
No. All right, sorry guys, my computer froze, so just give me 1 minute. Yeah. All right, so yes, if you guys get 15 mole per liter, that is the right answer. However, I do want you to practice on the scientific notation. So let's try this. If I give you 15 as a number, for example, right? Don't worry about the unit at the moment. If I give you 15, and if I'm going to ask you to write down this as a scientific notation, do you guys know how to write this in a scientific notation? Anybody?
Would it be 15 times 10 to the 1 power?
I think it would be 1.5 times 10 to the first power.
Yes.
Yes, so that is like 1.5 is the right answer. Yes. Look at this, right? Whenever you have a number like 15, what does it mean? If you do not have any decimal place, it means the decimal place is right after the number that you have. In this case, we're going to assume that we can say the decimal place is after 5. For scientific notation, if you remember the rule, it says the decimal place has to be after the first non-zero digit. It means you have to move your decimal place from like after 5 to after 1. It means your answer must be 1.5, right? Also, in scientific notation, you have multiplication by 10, and depending on how many places you move, in this case is 1, depending on which side you move, left, like you move from right to the left, so it should be +1. So this should be the right answer if I'm going to ask you to write down your answer in scientific notation. Do you understand that?
Yes, Professor.
Sir. Yes, Professor.
Yeah. So if I'm going to ask you to write down this answer in scientific notation, it should be 1.5 times 10 to the power of 1 mole over liter. Okay. Anybody has any question from this?
Yeah, for the
Mhm.
couldn't you also just have converted them 450 milliliters to liters in the first place, so you didn't have to.
Yes, that is right. However, I was not expecting that everybody know to convert this into a liter. So if you do that, it is right, right? It is.
So,
Yeah,
but
it will save you
but I
some.
think the way that I mean, converting milliliters to liters is easier. I mean, this is a lot of, you know, like it's more complex to do it this way than to convert milliliters to liters.
Yeah, you can follow any method you like, right? But not all the student has the same mathematical background. So I'm just trying to give a general idea which can be helpful for all the student if you're not strong in the math. If you know the math, then of course you can just do the math in your head, right? Like it is possible,
Okay.
right? So if you have a better method, of course I'm definitely asking you to follow the same method that you used to, right? This is just for somebody who doesn't know, like who don't have the strong math background. Yeah.
Okay.
All right, no problem. Any other questions, anybody? All right. So moving on to the next question. Oops. All right, give me 1 minute. Oops. All right, here. All right, so working on the third formula that we talked about. All right, so what the formula that says specific heat is equal to heat divided by mass multiplied by change in the temperature, right? Now, what is the change in the temperature? Remember this, every time when you have to find out the change in the temperature, or we can call it or represent it as a delta T. What is delta T? It is always T final minus T initial. It means what is your final temperature minus what is your initial temperature. Okay, so always remember this. We are not just always finding a positive temperature change. Sometimes it is a negative temperature change, right? And it is possible because in this courses, you are going to learn about different type of reaction. In some reaction, it absorbs the energy, some reaction, it releases the energy. And depending on those kind of reaction, the temperature change could be a positive change or could be a negative change. So for this course, please remember every time when you have to find out delta T, you are always going to subtract your initial temperature from your final temperature. Okay. So that's how we can find out change in the temperature. Let's look at the question. It says, how much heat is required? The question says, how much heat is required? This is what we have to find out. For 23.3 gram of the metal rod to increase its temperature from this to this, right? From 22 degrees Celsius to 28 degrees Celsius. Okay. If the specific heat of the metal rod is given, right? It means we have the specific heat value for the metal. We have the mass, which is 23.3 gram. We have the delta T, like two different value for the delta T. So if we're gonna apply that formula, delta T is equal to T final minus T initial. Final temperature is 28. Initial temperature is 22. So difference is 6 degrees Celsius, right? Everybody agree?
Yes, Professor.
Yes.
Right? Yeah, awesome. Right, in this case, what do we have to find out? We have to find out this heat, right? We don't have to find out the specific heat. It is given to us. We need to find out this heat. So what we're going to do, specific heat is equal to heat over mass. I'm just going to call it as a delta T, which is change in the temperature. Now, if we have to find out the heat, what are we going to do, right? So in the second formula, right, the last formula that we talked about, we see that all we have to do is just simply plug in the numbers in the formula and we do the math. In the first formula, we talk about how to find out if something is in a denominator. In this formula, what we are trying to find out is how to find out something is in a numerator already. However, it also have other quantities with it, right? So it has a mass and it has delta T. If we have to find out heat, it means we need to isolate heat by itself on the one side of the equation, and everything else, in this case, mass and the delta T, must be on the other side of the equation. So what we're going to do, we are going to multiply, because this mass and the delta T is in denominator, we're gonna multiply mass and delta T on the both side of this equation. So mass times delta T times specific heat is equal to heat over mass times delta T times mass times delta T. So what I did, I multiplied the both sides of this equation by mass and the delta T. When I do that, I should be able to cancel out the same quantity from the numerator and denominator. It means I can cancel out the mass and the delta T. Do you guys follow this?
Yeah, Professor.
Yes, sir.
Yes,
Yeah.
Professor.
Excellent, excellent. So what is going to be our final formula? Final formula is this. Okay, I'm just going to put the heat on this side. Heat equal mass time delta T time specific heat, right? So when you multiply this three quantity, you get the heat, and that's how I write this. So now this formula is really simple, right? All you have to do is plug in the numbers that you have in the part of the question as well as what you found out and do the math. All right, so this is kind of how to rearrange or shuffle the equation where you have to find out something in a denominator, something in a numerator, or if you just simply has to use the formula. Okay, that was the purpose of this question. All I'm going to do is I'm going to ask you to do the math and let me know what is your final answer. Okay, so plug in the right values and let me know what is your final answer.
My question is, when you're writing your value, how many numbers are you supposed to put down?
What do you mean? Like for the math?
For the significant figure,
Yeah.
how many significant figures are you supposed to express?
When you plug in the numbers, you always write down all the numbers which is given to you as a part of the question. In this case, for the mass, 23.3 gram has been given to you. So you do not change anything. Whatever you have given to you, you use them. Delta T 6.0. Why I say 6.0? Okay, so in this case, I should have, right? If I want to give you a better question in which we have enough number of significant figure, I should have given you as in this form, 22.0 and 28.0, right? If I do that subtraction, and as you guys may remember the rule for the significant figure for the subtraction, it must have fewest number after decimal place. So the number would be 6.0 degrees Celsius, right? So 28.0 minus 22.0, answer would be 6.0. This is your answer in correct number of significant figure, right? So I'm going to use 6.0 at the moment, which is delta C, so degrees Celsius. For specific heat, it is 1.67 given, so we're going to write that down, 1.67. The unit is calorie over gram degrees Celsius, so we're just going to write that down. Now, when you do the math, that's when you have to think about how many significant figure you should have in your final answer. However, the way I like you to approach this is just simply do the math. Use your calculator and find out whatever number you get. Then you think about how many significant figures you should have. Okay, so that way you won't make a mistake. Do you follow?
I actually was asking for the final answer. How many figures were we supposed to have?
Okay, in that case, what you think? We talk about the rule, right? In a significant figure, what we are doing, we are multiplying this. If it's a multiplication, how many, what is the rule for the multiplication? Do you remember the rule?
It has to be one after after the comma. Whatever the fewest.
The fewest significant figure.
Yes.
Right? If we talk about multiplication and division, your answer must have the fewest significant figure. For that, we are going to look at this number. How many significant figure do we have in the first number? We have 3. How many significant figure do we have in this number? We have 2. How many significant figure do we have in this number? 3. So your final answer must have only
2.
2 significant figure. Get it?
And that applies before the decimal point or after the decimal point?
No, that is the different rule. That's what I'm saying. Decimal point rule apply when we are doing addition and subtraction. Multiplication and division, we only talk about the significant figure. It means total number of digit must be only 2. So your answer must have only two digits.
So then the answer is 230?
24.
Okay, what answer you get when you do the math?
233.466.
24.
Sorry, 233.
0.466.
0.466.
Do we have to round it round off?
Yes, now you have to round off, right?
33.5.
What is it? 20.
33.5 after rounding off.
Oh no, you have to round off. Also, you have to think about the significant figure, right? If I say like you have to write down your answer in correct number of significant figure, it means there should be only 2 significant figure, right? It means you're gonna move your decimal. Okay, I should. All right, so you should move your decimal point all the here, right? Write down. Okay, I think, yeah, that would be better. So let me explain it in this way, right? If I'm not sure if you guys know all the rules, but let's talk about this, right? This is really interesting question. So for answer as 233.466, there are 2 ways to round it off. The first way is just to have 2, 3, and we should have only 3 significant figures. So 230. All right. What I did here, I round it off in such a way that my answer has only 2 significant figures. The answer looks like 233. 233, it is closest to the 10. It means 230. 230 is my right answer if I think about 2 significant figures. Right? Do you follow this?
Yes. Yeah.
Yes.
This is one way to present it. There is another way to present it is like a scientific notation. In scientific notation, what I had to do, I had to move my decimal place from here to here, right? It means between 3 to 4, sorry, between 2 and 3. So my answer should be 2.3 times 10 to the power of 2. Right? Do you understand this?
Yes.
Everyone? If you want, we can practice on this problem too.
I'm
Right.
sorry, but the answer that is given after we do the multiplication for the 3 specific heat mass and the change of heat, it's not 233.466. It's 236.262, which does not give you 2230. It gives you 240.
All right.
That's not what I got. I got 233.466.
Yeah, let me just do
Yeah,
the
233.4.
233.46.
I did it 3 times and it gave me 236.262.
No, actually, the answer looks like 233.466. So there is right answer.
Okay, I'm sorry.
Yeah, like maybe you are using this because you're not using any of this, right? Because this is like a significant figure. You're not using any of this, right?
No.
Okay. All right. So if you have a question about that, right, about the math, we can definitely discuss that. However, I think this is really interesting. So I think let's talk about this to make sure that everybody is on the same page, right? Rounding off in such a way that you have certain number of significant figure. There is a question.
Question.
Yes, go ahead.
So the temperature, we have to put like a decimal point on it always?
Yeah, like I should have given you a decimal point after that, because the reason is, right, if I just give you 28 and 22,
Mhm.
if you just do the subtraction, your answer is going to be 6.
Yeah.
In that case, when you write only 6 as your math in here, you have your final answer must have only one significant figure,
Okay.
which will not make sense.
Okay. But if we have a problem in a test, you're gonna give us I mean, it's gonna be there, the decimal point, right? Just to make sure.
Yeah, in generally, right? In generally, what I'm saying is, if I'm creating a question, I should have created a question in which your final answer must have at least 2 or more significant figure. If you have just one significant figure, it is not it's not going to be appropriate question.
Okay.
Yeah. So I should have designed it in this form, not as 22 and 28. It should be 22.0 and 28.0. Yeah.
Yeah.
Okay. There is a question in the chat. It says, so we always need to write the answer based on the significant figure. Yeah, every professor is different, right? For me, if you're taking my class, I always like to ask particularly that I want you to answer in significant figure, correct number of significant figure for every question. If I do not specify that I want your answer in correct number of significant figure, then if you do not write your answer in correct number of significant figure, you should get the full point. But every professor has a different preference, right? So I like to focus on such kind of question where I specifically mention that I do want you to answer as a specific significant correct number of significant figures. Okay.
And when you're writing the answer, when are we going to know when you want it in scientific notation or when you want it in regular?
Yeah, definitely. For me, when we are talking about this, because we are talking about scientific notation, we all like because we are talking about significant figure, we are going to apply that rule all the time. However, in your lecture, you should ask your lecture professor. If you are in my class, I'm going to announce that, okay, when I'm going to ask you a question, I'm going to mention that answer in correct number of significant figure as a part of the question. So you know that whenever you finish your answer, you have to convert that into the correct number of significant figure. If I do not specify, I do not expect you to write that in a correct number of significant figure. For now, we are going to apply that all the time. Yeah. For all the math that we do, we're going to answer in a correct number of significant figure because we are just practicing right now. Make sense?
It does, but my question was for the answer, when are we going to know when to put scientific notation or decimal notation?
Okay.
Since there's both of them as the option for an answer.
Yeah, that doesn't matter, right? You don't like, even if you write decimal notation or the scientific notation, both way you get the same point, right? Answer is right. It is not a preference that whether you have to have your answer in decimal notation or the scientific notation. You can put down any way you like, whichever method you find easy. Okay, so
okay. Thank you.
Yep, no problem. You can say 230, you get a full point. 2.3 times 10 to the power of 2, you still get the full points because the both has the same value. Yeah.
Yep.
All right. Any other questions?
No, thank you.
Yeah. Okay. Moving on. All right, so I don't have that. Okay, so this is, I'm going to stop sharing this. And what I'm going to do, I'm going to share a whiteboard with you so I can right now share. All right, so let's try to kind of understand rounding off rule, right? Just to make sure that everybody is on the same page. Let's say if I give you a number like this, 2.3, I shouldn't give you 2. Right, clear. All right, so yeah, let's say 850 and okay, so if I give you a number like this, 1850, right? And if I'm asking you to write down in a 2 significant figure, what would be your answer?
1.8.
1.9.
1.9, yeah.
0.9.
0.9. Just
Or
that?
19.
Sorry?
Or 19.
19. Okay, I think that was the part, right? Before I ask you if you guys know how to round off, and when you say like most of you guys said yes, I thought like, you know, you guys know this part as well, but it looks like you guys not aware of this fact that if you say 1.8, 1.9, 19, that is not the right answer. I think that's
1900s.
what you said.
1900s.
Yes.
Yes.
Right.
1090.
Yeah, 1900 is one way to present it when you talk about the decimal notation, right? If you just round it off in a correct number in a decimal notation, then it should be 1900. If you want to round it off in a scientific notation, it should be 1.9 times 10 to the power.
Power third.
Yeah, 1, 2, 3, 3. I think this is the part where which we need to understand before we kind of, you know, talk about, you know, that's why we get stuck in the previous problem. This was something which is not clear. So what we have to do, for example, when we have a number like this, and if you have to round it off to the 2 significant figure, it means we just need to think about the first 2 digit, which we're going to keep. Everything else is going to be considered in the rounding off. Now, I think everybody know the rules for the rounding off, that if the number is 5 or greater, you are going to add +1 to the last retained digit. However, you are not just going to get rid of those, right? When you round it off, we say 19 because you just add 1, right, to the 8. However, for these 2 places, you can just forget about it. You have to put 0, 0 to make sure that the value stays same. Otherwise, 1850, right, 1850 is not going to be equal to 19 when you say it is 19. Or if you say 1.9, this value is not same. This is 1000 and you are making it equal to 1.9, which is not the same value. Whenever we talk about the rounding off, the value should remain almost same, right? 1850 to 1900 value stays same, that it is more than 1000, 1800, 1850, 1900. All right, so that's what you need to understand. Do you follow what I said here for this part, for the decimal notation?
Yes.
Yes.
Yeah.
Yes.
The same way for the scientific notation, right? If you are more comfortable doing a scientific notation, then you know that in the scientific notation, you are going to move your decimal place. I'm going to rewrite that from here to here to here to here. Now you know you need to write down answer in 2 significant figures. So it should be 1 and 8. This is going to go, right? This is going to go away. The last written digit should have +1 now because the number is 5. So it should be 1.9. And how many decimal place did you move? 1, 2, and 3. So it should be 3. Okay, so that's what we have to think about. Now, is this the right answer or is this the right answer? Yes, both are the right answer. It's just a preference of yours that if you are comfortable doing this rounding off in a like a decimal notation or the scientific notation. Yeah, is this clear to everybody?
Yes.
Yes.
Right, I think that's the part where we get stuck last time. Yeah, any question? Anybody has any question?
Could we do one more example?
Yeah, sure. I'm just gonna give you like a really similar number, so I can explain you something else as well, right? Let's say if I give you this and I'm asking you to do the same, what should be your answer now?
1800s and 1.8 times 10 to the third powers.
Okay. Everybody?
Agreed.
1800 because the 3 is less than 5.
Yes, great, great, right? So I hope you get, that was my idea that yes, you guys should focus on this number too, right? If you want to get rid of those number and that is less than 5, it means when you're going to round it off, it's not going to be 1900. Now it's going to be 1800. And if you know the 1800, then you will definitely figure out that it is going to be 10 to the power of 3. Sorry, 1.8 times 10 to the power of 3. Okay, so you are definitely going to have such kind of question as your part of the homework, right? So when you practice on such kind of question, it will be clear to you, right? But I think it is clear to everybody now. Yeah,
Yes, sir.
Yes, sir.
good, awesome,
Yes, thanks.
awesome, no problem. All right, all right. So now what we are going to do, we are going to briefly talk about the periodic table, how to read the periodic table, what information we can get from the periodic table. Okay, so I'm going to stop sharing this and go back, share screen. Do I have my periodic table? All right, share right here. Share. All right, so welcome to the chemistry. It's periodic table. We are done with the math for now. All right, so how many of you guys have seen the periodic table before? Say yes.
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 Yeah.
Yes.
Okay. Not so many then. Okay, so this is how the generally periodic table look like, right? If let me see if I can draw something. Yes, I can draw. So the general, I would say, design of the periodic table is this. We are only going to focus on the top part, which I just kind of circle with the red line. All right, that is our periodic table. Just for your knowledge, you can keep in mind that there are total of 118 elements that we know as of now, right? The research has already been going on. If we find out new element, we're just going to keep updating this table. However, at the moment, we know 118 different elements. Okay, what are the elements? Every box that you see in this table, right? Every tiny box, right? Let's see if you see this box. If you see this box, every box in this table is referred as an element. So if you want to understand what is an element, it's really simple. Every box in this periodic table is called as an element. Okay. Now, what we're going to talk about, we are going to talk about what we have a particular names for. So you can see there are rows. All right, can I write that? All right. Okay, I can. So you can see there are columns, which you see the number 1, 2, 3, 4, 5, up to 18, right? Generally in the table, we refer this as a column. However, in the periodic table, we refer them as a group. All right, so please remember this. Every time when your professor or in the book, if you see a word group, it means it's the columns in the table. All right, columns of the periodic table is called as a group, while the horizontal rows, right, these rows which you see 1, 2, 3, 4, 5 up to 7, they are called as a period. Right, I'm going to write that here. That is called as a period. So if you see the word period, it means it is referring to the horizontal rows across the periodic table. So please remember, there is a group which is column. There is a period, which is rows. Yeah, make sense?
Yes.
Yes.
Right? Okay, let me see. Now, what we're going to talk about, we are going to talk about what are these 118 numbers are. So the number, if you look at each box, let's focus on each box. Can I erase this? Let me see if I can erase this. Okay, probably later on. So I can just focus on the other one box here. Oops. All right. Undo. Oh, oops. All right, so if we just focus, oh man. All right, okay, I had to stop sharing this. No, it worked. My computer, right, that's fine. Yeah. All right, so I think I have to stop sharing this. Sorry, guys. Share screen. Okay, sure. All right, let's see this. Clear, all right. Oh, wow. Okay. What I can do? I can close this. Okay, so let's focus on this side of the periodic table. All right, so guys, please look at the table. Look at the table, column number 2, and the horizontal row number 3, right? Sorry for this. I think my computer is kind of slow. So are you guys looking at the box number 12, everybody?
Yes.
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 Okay, so if you look at the every box in the periodic table, you will see a symbol for an element. In this case is Mg. You see the name for the element, which says magnesium, and you see a 1 number on the top and 1 number at the bottom. So the number on the top, which is 12 in this case, it is called atomic number. All right, if you have my handout, please keep that handout open with you, right? So you can refer to that. Atomic number, we are going to talk about what is atomic number means and more detail tomorrow, but just keep in mind the number that goes up sequentially across the periodic table. So if you look at the first box, it says number 1. If you look at the second box on the right side of the table, it says number 2. If you come to the second row and if you look at the left side, it says number 3, then it says number 4, then it says number 5, and so on, right? So that there is a number which goes up sequentially from 1 to 118. That is called atomic number. So what we can say, the periodic table has been arranged depending on their atomic number, right? So it is in the order of the atomic number. What number you have at the bottom then? So the number at the bottom of each box you have, which has a decimal place in it, right? So let's focus on the box number 12 that we talked about earlier. So there is a number which says 24.305. What that number means? That number is called mass number, right? So the number which is on the top is called atomic number. The number at the bottom, which has a decimal place, is called mass number. All right. What atomic number tells you, what mass number tells you, we can discuss it tomorrow. All right. But keep in mind the number which goes up sequentially, which does not have decimal point, it is atomic number. The number that has a decimal point is a mass number. Now, in terms of the group, we have different names for the group. What are those names? So we're going to talk about the names. Okay, I think I have to read it because I need a clear table. More. All right, close this. Yeah. All right. Clear this. All right. So now we're going to talk about different name of this group. So there are 4 names that you should be familiar with this. The name is only for the group. So group number 1 has a particular name. Group number 2 has a particular name. Group number 18 has a particular name and group number 17 has a particular name. So instead of just referring them as group 1, group 2, group 17, group 18, we can refer them as different name. What are that name? Number 1, group number 1 is called alkali metal, which is right here. The group number 1, it means every element in the group number 1, or we can say column number 1 is called alkali metal. Group number 2, what do we call that? Group number 2, we call them alkaline earth metal. So every element which you see in the group number 2 or column number 2 is called alkaline earth metal. Okay. Group number 18, what do we call that? We call them as a noble gases. Why do we call it noble gases? Because they generally do not react, right? But we can talk about that later. At the moment, let's just try to understand the names. Noble gases. And group number 17 is called halogen. I'm not sure why they didn't put this here, but group number 17, they are called as a halogen. The reason why I'm referring to this name is in the exam, instead of just giving you the group number, question can be asked as a name of this group, like tell me the name of the element which is present in a halogen group. Tell me the name which are present in a noble gases group, right? So just keep in mind. So these are the 4 group names which you should be familiar with. Everybody understand this? Yeah, so far so good?
Yes, sir.
Yes, sir.
Yeah.
There, thank you.
Okay, great.
Professor, it's actually written on the top of the group 17. I mean, on the
Oh,
bottom
yes.
of 17,
Yeah, I see that here too.
but it's too small.
Yeah, it's too small. All right, so great. Thank you for pointing that out. But you don't have to worry about the name for the group number 15 and 16 and 15 and 16. Generally, as an introductory level courses, we don't use this name for this group number 15 and 16. So these are the 4 names which you should be familiar with this. Okay, you don't worry about the other names. Now, if you want to generalize or generally categorize this periodic table, we can categorize into 3 categories. What are they? Metal, non-metal, and metalloids. Let me see if I can find that somewhere. Okay, it is here. So I can point this out. If we want to categorize this periodic table into 3 categories, the first category is called metal. Second category is called non-metal. And the third category, we can call it as a metalloids. Which are the metal? So the metal is up to this point. So I'm gonna draw this line so you guys can visually see this. All right, this is metalloid. All right, so you see the zigzag line that I drew. The element in between them is referred as a metalloid. So I'm not done yet. I'm just trying to make sure that I have it right. right? So it's like a stair. You see the stair? Everybody can see that? The box number 5, 14, 32, 33, 51, 52, 85, right? These are the boxes which are a part of the stair. Those are the called metalloids. What is metal and what is non-metal? We're gonna learn about that on Tuesday, right? So we can also talk about what is metalloid. However, I'm gonna help you to understand where we can find the metal. So when we look at this stair, which is a metalloid, every element on the left side of the stairs is called metal, right? So I'm just gonna draw this like really vague, but all of this are called metals. So this all element which are on the left side of this metalloid, or in general we can say left side of the periodic table, is referred as a metal. The right side of this periodic table, which is and everything on this side of the stair, right? The other side of the stair are called non-metals. And the line that separates them, that is called metalloids. Okay. However, there is one exception, and the exception is hydrogen, the first element. The first element, which is hydrogen, even though it is present on the left side of the periodic table, it is a non-metal. So this is only exception. Otherwise, we can generalize that left side of the periodic table is a metal, right side of the periodic table is a non-metal. All right, do you understand this? The exception is hydrogen. Everybody's okay?
Yes, sir.
Yes.
Sir.
Yeah. Excellent, excellent. That is okay. So let me just stop, clean this. All right, so erase. All right, erase. Erase. Now, there is something you should know about the periodic table, which we don't have here, is when we talk about this group number, which is here from number 1 to 18, we don't just have one way to label this group. We have another way to label this group as well. What is that group? If we want to represent it other way, it is going to be 1A, then it's called 2A. So we are using letter A after the number. Then we're gonna move on all the way on the right side where it says 13. So we're gonna say 3A, 4A, 5A, 6A, 7A, and 8A. All right, I want all of you guys, whenever you find a print out the periodic table, make sure you write this label as A as well. It tells you so much information for your course, right? You have to keep them handy. You should know where are the A's. It is looks like really simple. 1 is 1A, 2 is 2A. Then we're just going to skip the middle section of the periodic table, which is kind of small section, right? If you look at this section, the periodic table in the central section, it is with the is smallest section, right? So we're going to skip that and we're going to start it from this point once again. So 13 is 3A, 14 is 4A, and 18 is 8A. What does it tell you? It tells you a lot of information. Again, we are going to talk about that in Tuesday's lecture. Okay, so please keep in mind that there are two different ways to label the group, 1A and 2A up to 8A. The second one is just give them a numerical values 1 to 18. The central section of the periodic table, which I just highlighted here, it has a specific name, which you kind of should know this. Not everybody is referring to this name. However, you should know the name that is called transition metals. All right, the central section of the periodic table, starting from this point to this point, right? This square is referred as transition metal. Why do we call that everything? We are going to learn that in the next session. Okay, so that is called transition metal. Everybody's good?
Yes, sir.
Yes.
Yeah?
Yes.
Excellent. Now, don't get overwhelmed with this periodic table. Do you have to remember all the symbol, all the names, all the numbers? No, you don't have to. What I would suggest you to do, spend some time to remember the name of the element and the symbol up to the 36, up to this point, because those are the one which are going to be a part of your syllabus. Okay. Do you have to remember them in sequence? No, you don't have to. Will periodic table be given to you during the exam? Even if you are taking an in-person exam, yes, periodic table will be given to you. However, that periodic table will not have the name, right? The name that you see here will not be there. You only can see the symbol. So when you see the symbol, you should know what should be the actual name, right? So that's what you have to remember. So what I would say, you should try to remember the symbol and the name for it up to 36 element. So if I say Cl, you should know it is chlorine. If I say S, you should know it is sulfur. In most of the element, right, the symbols that we have, they are generally referring to the first or the second letter. There are only certain cases in which it is not referring to the first or second letter. For example, H is hydrogen, so it's the first letter of the hydrogen. Helium, He, is a helium. Lithium, the third one, right, Li. Beryllium, Be. So most of them does follow this first or second letter. However, there is exception like sodium, the number 11, box number 11. We call it as a Na. The symbol is Na, but the name is sodium, right? So this is something you just need to kind of, keep repeating yourself, reviewing this, practice this, so it will come to you easily, right? So it's not that hard. And there are only few of them which does not follow this way. Also remember this, every time when you write the symbol, the first letter of the symbol must be capital, right? Let's say if you talk about boron or carbon or nitrogen or oxygen or fluorine, when we represent it using just one letter, it has to be capital. But if there's an element which we use two letter to represent, then the second letter must be second small letter, right? So He, E is a small letter. Ne, N must be the capital, E must be the small. Ar, argon, A must be the capital, R must be the small. Okay? Do you guys follow this?
Yes.
Yeah. Yes, sir.
Yeah, sir.
Okay, excellent. So with this, it's already 12:57. So we kind of touch the basis, all all the information that we need from the periodic table. We already discussed that. I don't want to continue with the atoms and the element theory right now. We can continue that discussion in the next session. Okay, so I'm going to stop sharing this. But before I do that, is there anybody has any question on this?
No.
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 Anybody has any question? No. Okay.
No.
All right. So I'm going to stop sharing this. Again, I would like to thank you guys for your time. Right. Thank you so much for paying attention. If you have any question at all, you guys can more than welcome to stay. You can ask me the question. If not, then I'm going to see you on Tuesday at 11. Okay. As soon as the recording is available to me, I'm going to post it and I'm going to share it with you via email. Okay. Thank you so much for your time.
Thank you, sir.
Thank you.
Have
Have a long weekend, guys.
Appreciate it.
Thank you.
Right.
Thank you.
Bye.
Thank you. Have a good weekend.
Have a nice weekend.
Thank you.
Bye-bye.
Professor, just a small question.
Yes.
So we are not meeting tomorrow nor Monday, only Tuesday and Wednesday?
Yes. Now it will be Tuesday and Wednesday next week.
Okay, cool. Thank you.
Professor,
Yes.
Professor, is our class going to be in person or online?
You can check on the CUNY first, but most of the lecture classes are online.
Uh-huh.
Some of the lab classes are in person.
Oh, okay.
So
Thank you.
please check on the CUNY first.
Yeah, sure. Thank you.
Then I'm gonna ask another. I was put in another class, but then it's a lady who's the professor. Can I still come to these classes or I should not?
Okay, can you repeat your question? You were in the other class then?
So I was in a class, but I think there were not enough students, and I was put in another class. Can I still come to this pre-course?
Oh yeah. This is like, yeah, you can definitely come in, right? You don't have, like, you already have the link. This is just an information session, right? I'm just trying to help you guys out. So you guys can definitely, like, even if you drop the class, you can still come in, right? So that's no problem.
Okay.
Yeah.
Okay. Thank you very much.
No problem.
Have a good
Bye-bye.
Professor, are you still sharing the link to the textbook for each course?
Oh, yes.
Thank
I
you.
think most of you guys are left. So let me do one thing. When I'm going to share the link for the video, I'm going to share the link with, I'm going to include that in the email as well. That if you're taking 110, this is the link for the book. If you're taking 201, this is the link for the book. That sounds good?
Okay, thank you so very much. You have a good day.
You too.
Thank you, Professor. Bye. Have a nice weekend.
You too.
Enjoy. Bye.
Yeah. Take care.
Professor, can you repeat what you say about the book that I didn't
For the book, like many students ask me to share the name of the book that you're going to use. So, like this, we have the group of the student from the 2 different classes. So what I'm going to do, when I'm going to share the email, I'm going to send out to you the email with the link. For the recording. I'm also going to send out the link for the book. So depending on which class you're registered for, you can just use one link. Let's say you are registered for 110, right? Are you registered for 110 or 201?
201.
201. Okay. So in the email, you will have the link for the recording. You will have the link for the book if you are taking 110 class, and you will have the link for the book if you are taking 201 class. So all you have to do is just click on the link for the 201 class, and you will have the book. It's like a PDF version, right? So now everybody use like an open book resource, like open education resources. So it's like a free book which you can download if you like to, or you can just have an online access.
All right, thank you, Professor.
Yeah, no problem.
See you next week.
See you.
Professor, I had a question. I was kind of lost on that molarity problem that we did. And I think I was partially confused by the difference between molarity and a mole.
Okay.
So is a mole, I thought that was like an abbreviation for molarity.